Geometry Common Core, the June 2016 Regents exam, number 36, the final question of the exam. So this is a volume part 4 question, and as I've mentioned in I think the past couple of videos that the state recently changed the format at the time I'm making this video to go away from 2 part 4s and just have 1 part 4 question, and they specifically said that they're taking out the volume part 4. So the odds of you seeing a volume part 4 question are pretty slim. Now you will see volume questions. My guess is you'll see way more of them in part 3 and part 2 and of course part 1. But a question like this as a part 4, probably not so much. Now it's not that this whole question is too difficult. Like if you were to just take out maybe one of these things, it could easily be a part 3. So that's why we definitely want to still go over it and be prepared for these volume questions. So a water glass can be modeled by a truncated right cone, which is a cone with a cut parallel to its base as shown below. And so there's your water glass. It's a cone with the top cut off. Top meaning the pointy part. And it's almost like a trapezoidal cylinder kind of thing. So the diameter of the top of the glass is 3 inches. So this is 3 inches. The diameter of the bottom of the glass is 2 inches. This is 2 inches. And the height of the glass is 5 inches. This is 5. Now, what you really need to pay attention to in volume questions, especially the part 3s if you have one, is any conversions. They gave me inches, they gave me inches, they gave me inches. This question actually does not have any unit conversions on there, but that's become very common for the Common Core Geometry exam, where they'll give me this is in inches, but this is in feet, or something like that. And so you have to make sure everything is in the same unit before you start doing volume formulas. All right, so that really isn't they're just kind of giving us information there. The first question says the base with a diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Explain why. So basically what we want to do, the next question is find the height of the cone. So like this diameter is 3, this is 2, this is 5. What they want us to find is this height here. And they're saying, why do these have to be parallel in order for that to happen? And the reason is because we're going to use similarity proportions. And similarity proportions, or the side splitter theorem or small over large and stuff like that, that results when these things are parallel. I find this to be a very difficult thing to answer in words here, and typically in an exam they usually don't want it to be as complicated as I end up explaining it here. And first of all, they tell you that it's parallel. But why does it have to be parallel? Because what this does is if the bases are parallel, the cones are then similar. And by the cones, I mean, the big cone and then this cone. The big cone with the base of 3 and the little cone with a base of 2. And I think that's honestly probably enough to answer the question. But I would probably go a little further and say if the bases are parallel, the cones are similar, and we can then use a proportion to find the height. Oops. Sorry, maybe that happens. So that's going to be my answer to this part right here. Like I said, take that out, and it's probably a part 3. Determine state in inches the height of the larger cone. So we have to do small over large, but our small cone is this cone here, not the water glass, if we're talking about similar cones. So our small cone, we don't have an expression for. We can make the smaller cone, since we know this whole thing is x and this is 5, we can make the height of the smaller cone x minus 5. And so if we want to say like the small base is 2, the large cone base is 3, the small cone's height is x minus 5, and the large cone's height is x. and cross multiply this proportion. 2 times x is 2x. 3 times x minus 5 is 3x minus 15. Don't forget you have to distribute 3 times the x and the 3 times the negative 5. I would likely minus 3x then. Let's get negative 1x equals negative 15. Divide that negative 1 away to get the height of the large cone is 15. All right, and so that is our answer here. And then lastly, determine and state the nearest tenth of a cubic inch, the volume of the water glass. It's kind of like area of a shaded region in a sense, where what I could easily, now that I know the heights of these things, like this has a height of 15, which means that this is a height of 10, I could find the volume of the big cone, and then I could find the volume of the little cone, and when I subtract them, I will be left with the volume of the water glass. And so that's exactly what I'm going to do here. Now, one thing you have to be careful of whenever you're doing volume formulas, especially things that have circles, they always give you diameter. But what you always need is radius. So for the big cone, the height we figured out is 15, but the radius is 1.5 because the diameter was 3, right? We got to cut that in half. So the volume of that is 1/3 pi times the radius squared, 1.5 squared, times the height of 15, okay? And our small cone has a height of 10. Again, we see that here because the whole thing was 15 and we know the height of the water glass is 5, so the height of 10. And the diameter was 2, so this one has a radius of 1. And we're going to subtract this volume, so minus 1/3 pi 1 squared, which is just going to be 1, times 10. And you could type this whole thing in as it is and then just round the answer like that. Or if you wanted to get this value and then get this value and then subtract them, that's fine. Just make sure you don't round those values before you subtract them. You don't want to round anything until the very end. So let me type them in one at a time just so you get an idea of what the numbers are. And so let me pull up my calculator. And I'm going to turn it on, clear what's there. I'm going to do the alpha y equals enter feature so I could type 1/3 the way that I see it. So 1/3 of pi times the radius of 1.5 squared times the height of 15. And this is going to give me the volume of the big cone. And then I could do alpha y equals enter and do 1/3 pi times 1 squared. I know that really isn't going to do anything, but I'll type it in anyways. And that cone has a height of 10, and I got this. And so 35.3429. So this one was about 35.3429 ... to remind myself that that's not the exact volume. And 10.4719. 10.4719 ... Again, I'm not going to use those numbers. I'm just writing them down as reference. But I want to subtract these values. And again, I could type that whole thing in, or with my calculator, I can go up and highlight and do minus, and go up and highlight, or I could do minus second answer, which is the previous result of the 10.471975, so on. And that is the answer that I can round. So 24.87 rounded to the nearest tenth is going to be 24.9 for the final answer. 24.9. That's it. All right, so not too bad, especially because there wasn't a unit conversion anywhere in the problem. But that is the final question of the June 2016 Regents exam. Thanks for watching the videos. See ya. Good luck.